In this video, we're going to find a natural number n such that 1 over sine of pi over n equals 1 over sine of 2 pi over n plus 1 over sine of 3 pi over n. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. I'm going to present two methods. My first approach would be to combine the two fractions at the right. So I will have 1 over sine of pi over n equals sine of 3 pi over n plus sine of 2 pi over n, all divided by the product of the two sines. Then I will cross multiply, so then I will have this product of sines to be equal to 2 other blocks of product of sines added together. Now at this point, I'm going to use the product to sum formula. Which says that in general, if I have two variables sine A, sine B multiplied together, then I can see that as half of compound angle formulas cos A cos B plus sine A sine B, and then subtracted by something similar, but this time it's the difference cos A cos B minus sine A sine B. For the first part, it is actually cos of A minus B, the compound angle formula, while the second part is cos of A plus B. So then if I have products of sines, then I can write them as difference of cosines. And going backwards, if I have some difference of cosines, then I can actually say it's equal to 2 times, maybe I'll just do the derivation as well. In fact, I'm going to look at it this way. Splitting A into some of these terms, so then B would become the difference of these two terms. And at last, I will have 2 times sine of those two expressions. Sine done separately on A plus B over 2 and A minus B over 2. So I'm going to make use of this. Now going back to our equation, for the left side, I'm going to have half of sine pi over n. I'll just take it as A equals 3 pi over n and B equals 2 pi over n. Maybe I'll write it this way, so it's easier to see. This sine subtracted by sine, it's cosine, which equals to half of cos 2 pi over n minus cos 4 pi over n. The other part is also plus, as it's also half of cosine, so I'll just keep it in the same bracket. First cos pi over n and then minus cos 3 pi over n. Now both sides have done 1/2, so I'll remove them. Now I can also remove the cos pi over n as well. So then we have 4 terms about cosine in this equation. Now to proceed, I'm going to move the cos 3n, the last term, to the left. So then the difference of the fraction inside the cosine on both sides will be the same. So then as you can see, 3 and 5 has a difference of 2, while 2 and 4 also has a difference of 2. So then when we do the cos A minus cos B equal double of the product of sides, then we'll have something to be equal on both sides again. Now using that formula, I can say 2 times sine of 3 plus 5 over 2, which is 4, and then multiply by sine of 3 minus 5 over 2, which is minus pi over n. Or on the other side, we'll have sine 3 pi over n times, again, minus pi over n. So then, at this point, either we have sine pi over n, taking out the minus, is equal to 0, or sine of 4 pi over n equals sine of 3 pi over n. Now for the first case, n can be 1 if n is restricted to be a natural number. But then it's impossible because from our original equation we want this to be we have this as the denominator, so we can't have 0 to be there, so I have to reject it. And actually we for this equation we need n to be at least 2. Now for the equation at the right, I'm going to move the sine 3 pi over n to the left. Now for difference of signs, I can say it as product of. I can just split the 4 pi. Imagine this is, say, plus pi over 2n, put it this way, while then 3 pi over n will be equal to the difference of these two fractions. So then, okay, it's actually sum to product. I'm going to write out more details. As to subtract, we will have only the last part of the compound angle formula, which is 2 times cos 7 pi over 2n sine of pi over 2n equals 0. Now, since we know that n is at least 2, so for the sine thing, this must be positive. So we must have cos 7 pi over 2n to be equal to 0. Now at this point we can see that there's actually only one solution for n, which is 7, because if n is larger than 7, then 7 pi over 2n is less than pi over 2. And so cos of this fraction must be positive. Now, okay, it's between 0 and pi over 2, so it's in, say, quadrant 1, and you can see that cos is positive. Well, otherwise, I can actually list the values out, starting from 2, because we know that 1 will not work. Of course, that is 0. Well, this is, I don't have to say cos, I just need to list out 7 pi over 2n, that will be sufficient. 7 pi over 4, 7 pi over 6, 7 pi over 8, 7 pi over 10, 7 pi over 12, and then for this is pi over 2. You can see that all these 5 fractions is not of the form like pi over 2 added by some integral multiple of pi. So you know that cos of it will not be 0. So that from this we can see that n equals 7. This is the only valid solution. My second approach would be to make use of the polar form of sine. So recall that in general for any angle, say theta, if I say e to the power I theta is actually defined by cos theta plus I times sine theta, a complex number. So to take out the sine, I'm going to consider the complex conjugate of this exponential power, which is e to the power minus I theta, and that is cos theta minus I sine theta. So then sine theta is actually the difference of these two powers divided by 2i. Putting this fact into our problem, we can say that sine of pi over n is equal to e to the power pi I over n minus e to the power minus pi I over n, all divided by 2i. And in fact, if I replace the pi over n by, say, 2 pi over n or 3 pi over n, then it seems that it's just these powers taken to a squared or cubed. So then the key to solve this equation would be to make everything in terms of these kind of powers. So I'm going to let u equals e to the power pi I over n, then e to the power minus pi I over n is just 1 over u. Now from this we can rewrite our given equation as 1 over u minus 1 over u. In fact, there is actually 2i. I can still write 2i for the time being, but we know that this can be reduced because all fractions contain this 2i. As I said, 2 pi over n is just in terms of u squared, while 3 pi over n is just in terms of u cubed. So then, simplifying, we'll have fractions like this. It's not even trigonometry, but it's just pure algebra. And you can do a lot of expansion on the right side. For the denominator is u to the power 10 minus u to the power 6 minus u to the power 4 plus 1. And with the cross multiply, we'll get these 4 terms at the left, 11, 7, 5, and 1, while for the right, we are going to have 10, 9, 5, 4, and then 8, 7, cubed and squared. At this point, we can remove the power 5 and 7 because both sides contain such terms. Then I'm going to move everything to the left, rearrange in this way, and you will know what's going to happen. The first 4 terms are power 11, 10, 9, and 8. And then for the other 4 terms, they are power 4 minus cube minus square plus u equals 0. You can see that for the first row, it's an arithmetic sequence, and then for the second row, it's the same, 4, 3, 2, 1. And then the arrangement of the signs, plus and minus signs, are exactly the same. So I'm going to group them in this way, the yellow group and the green group, and I'm going to factorize it. So for the first group, I can take out u to the power 8, and then u cubed minus u squared minus u plus 1. And then for the second group, they have the same expression inside the bracket. So we have u to the power 8 plus u factorized to be in this, while for the four terms inside the bracket, they end up become u minus 1 times u squared minus 1. So I'm going to factorize the difference of squares as well. The u minus 1 all squared times u plus 1 equals 0. So either u equals 0 or plus or minus 1, or u to the power 7 equals minus 1. Now recall that the so-called u is actually e to the pi I over n. Or I can say is cos pi over n plus I times sine pi over n. So for this to be 0 is actually impossible. Quickly rejected. While for 1 and minus 1, it's actually not possible for minus 1 because then n will be 1, and we knew from our first approach that this has to be rejected. And for u equals 1, that's also impossible because that means n is approaching infinity. So I can quickly reject that. Now for u to the power 7 equals minus 1, and it's just identical to our solution, which is that e to the power 7 pi I over n equals minus 1. Again, you can do the testing using a similar argument as the first approach. You will know that n equals 7 is the only valid solution. So these are my two approaches. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.